Greetings. Thank you for watching my video. I'm Professor Dan Capper from the University of Southern Mississippi in the United States. My field is science and religion dialogue, which I use to develop environmental ethics. Although I work within religious studies, I work as a secular researcher at a secular university so that I can develop secular ethics for secular settings. My book on environmental ethics in world religions perspective, Learning Love from a Tiger, Religious Experiences with Nature, spotlights how I welcome all religious and non-religious voices in the task of producing quality ethics. Hence, please understand that although I focus on Buddhism today as one source for morality, at the end of my presentation, I hope that you will support my proposal to protect selected areas on our moon with multi-purpose nature reserves, regardless of your own religion or lack thereof. Before I get into full gear, I also mention that, given my time constraints, I quickly will move past some details today. Further information regarding anything that I discuss can be found within the resources mentioned on my slides. Anyone who knows about our moon today knows that the gold rush for lunar riches already has begun. Numerous national space programs, alongside many private companies, seek to tap lunar resources and look for ways to establish a greater physical human presence on our moon. This means that you and I sit at the cusp of an important ecological moment, one that demands our response. Unlike environmentalism on Earth, which is forever in damage control, we still can retain our moon in relatively pristine form, but only if we begin discussions, think, and act now. We can dramatically change the ecological and scientific inheritance that we leave for future generations through thoughtful action today. Among the resources that people are seeking from our moon as a part of the gold rush is helium-3. In theory, helium-3, if fused with itself, will produce clean nuclear power without radioactive waste. Helium-3 does not exist much on Earth, though, since our planet's magnetic field deflects the arrival of helium-3 in the solar wind. However, our moon, lacking a magnetic field, has helium-3 broadly, if diffusely, embedded in the upper layers of its regolith. Mining this lunar helium-3 for Earth use poses some dangers. According to the helium-3 proponent Jack Schmidt, powering for 1 year a city the size of Dallas in the United States would require the processing of 2 square kilometers of regolith 3 meters deep. When you consider how many other power-hungry humans there are across the rest of the world, besides in Dallas, the multiplication of at least 2 square kilometers 3 meters deep per city really adds up. Additionally, that cost is just for 1 year, and proponents intend to power Earth with helium-3 for many decades. Thus, it is not alarmist to see the wisdom in Mark Williamson's argument from his book, Space, the Fragile Frontier, in which by the year 2060, we could lose the figure that Westerners call the man in the moon, and that many Asian Buddhists call the rabbit in the moon. Losing the man, or rabbit, in the moon will be an ecological, cultural, historical, and scientific calamity. In terms of the ecological problems, please note that if there's an ugly strip mine in Brazil today, almost no one watching this video will see that devastation. But if we destroy the rabbit in the moon, every human being will have a chance to notice the damage every night forever after. In addition, the figure called the rabbit, man, woman, or toad in the moon has played a part in world cultures for thousands of years. What right do we have to take that cultural experience away from humans who live 200 years from now? Losing the rabbit in the moon also would mark a space history tragedy, since the hardware from great lunar exploration achievements mostly rests within the figure of the rabbit in the moon. For instance, don't we want to protect Neil Armstrong's first human footstep on our moon rather than lose it to a mining robot? We can protect this footprint by preserving the region of the rabbit in the moon. Finally, erasing the rabbit in the moon feature will mark a large scientific loss, since industrially processing regolith 3 meters deep squanders a lot of that material's scientific value. How do we avoid these tragedies? By protecting our moon's surface while still allowing commerce? To answer this question, I turned to American Buddhists from the ethnographic field. With the permission of my university's Institutional Research Board, I gathered both quantitative and qualitative data from 121 American Buddhists who represent a cross-section of Buddhist traditions. So that we can separate Buddhist perspectives from more generically American ones, I also collected data from a control sample of 78 general public Americans. All of these field subjects took a 16-question space environmental ethics survey. Buddhist responses to the space ethics survey were illuminating, since the field subjects in this project excitingly supplied a new basis for understanding our relationships with our environment. As the table on the left shows, Buddhists generally argued for the protection even of a moon that lacks life. The table on the right indicates that instead of focusing on the importance of life, Buddhists alternatively argued on the basis of a perceived connection with our moon, and responded to this connectedness by extending the famous Buddhist value of ahimsa, or non-harm, even to a lifeless moon. However, emerging from the principle of interconnection and the value of non-harm that these Buddhist practitioners stress, Buddhism supplies another useful tool for environmental protection: a history of preserving important spots with nature reserves. Even during the lifetime of the Buddha 2,500 years ago, Buddhist nature reserves appeared. And today, Buddhists in many countries continue to protect valued ecologies with boundaries that delimit potentially harmful human behaviors. Combining the concept of protective reserves, together with the principle of interconnection and the value of non-harm that I have mentioned, we arrive at the heart of my proposal today, which is to protect at least 5 locations on our moon with multi-purpose nature reserves. This zone-creating strategy leaves areas outside of the reserves free for commercialization, while the reserves further preserve locations that demand safeguarding. Already I have argued for the importance of protecting the rabbit in the moon with nature reserves, and in a moment I will turn to the Malapare region near our moon's south pole. Right now, I focus on initiating reserves in the Peary and Flory craters area near the moon's north pole. Because of our moon's nearly vertical rotation relative to the sun, at both lunar poles, high altitude points may enjoy sunshine 85% of the time, while crater bottoms may never see a ray of light. These dark craters provide the immense virtue of fantastic, interference-free, naked eye or telescopic views of our cosmos that must make even gods gasp in their magnificence. Imagine camping under a vivid and seemingly endless blanket of stars with no atmosphere or light sources to muddy the view. Hence, the Peary and Flory craters region represents an outstanding spot to preserve for scientific, ecological, and recreational reasons. Further, protecting the Hertzsprung crater on the far side of our moon makes sense, since this spot offers both scientifically interesting ancient geology as well as a moon equatorial experience. Moreover, in preserving the region of the von Karman crater on the moon's far side, we appropriately commemorate the difficult to achieve first soft landing on the far side of the moon with the Chang'e 4 mission. If I now return to the Malapert region near the moon's south pole, I can simultaneously offer reasons for the preservation of the region, as well as crucially highlight how versatile in function this nature reserve proposal is. At the moon's south pole, many people want to mine sunless craters, erect solar panels on sunny highlands, or place line-of-sight communication towers on peaks. Accordingly, many proposals intend to place industrial hardware on the Malapert highlands near the South Pole. I respectfully offer that such thinking is short-sighted and not thoroughgoing. First, the Malapert area rests 100 kilometers from the actual South Pole, and there are many high places much closer to the pole that provide perfect opportunities for solar panels, line-of-sight communication towers, and the like. Thus, my proposal does not impede any of these industrializing activities. It simply rezones them like we do on Earth, as industry will thrive near the pole, while the more distant Malapert region avoids damage. As well, activities that are pursued sustainably, such as ecologically responsible telescopes, still can unfold within Malapert Reserve boundaries, following the model established by the United Nations Man and Environment Program. These reserves provide for the multi-purpose functions of pure scientific preservation, safeguarding for future recreation, and also industry that is pursued with environmental responsibility. But by protecting the Malapert region with reserves, we preserve one of the great treasures of our solar system with appropriate environmental, cultural, and scientific concern. The Malapert Peaks and Craters region consists of unique mountains that rise as high as the Andes Mountains and provide every bit of the sublime majesty that the Andes supply. We try to protect the Andes Mountains with nature reserves. Should we not protect the peerless Malapert Highlands similarly, so that humans 2 centuries from now can enjoy an unblemished Malapert scientific, cultural, and recreational experience? By protecting special regions while still allowing industrial development, the nature reserves that I propose here permit the desired commercialization of our moon, but do so in a way that also manages superb spots like the Malapert region with thoughtful social and environmental responsibility. I just mentioned that the multi-purpose strategy of these reserves is modeled on the successful track record of the UN's Man and Environment Program. However, Although that program is useful for helping us to conceptualize lunar reserves, because of some unique provisions within space law, the establishment and oversight of these reserves falls to the better placed UN Committee on the Peaceful Uses of Outer Space. Indeed, this committee already provides management of what are called special areas on Mars. My proposal today simply extends and formalizes such behavior on our moon. By now, I hope that you will see the wisdom of initiating the lunar nature reserves that I've described as soon as possible. In creating these special zones, we do not impede future lunar industry and commerce, but instead help to make lunar industry and commerce more responsible. By creating multi-purpose reserves that enrich and protect at least 5 noteworthy places on our moon that retain value beyond what can be measured by mineral prospecting, we benefit human science, culture, history, and future recreation simultaneously. Thank you for your time.